This video is to help you with permutation matrices. So if you notice matrix P from your notes is a square matrix, it has 3 rows and 3 columns. It is also a binary matrix because all the elements inside matrix P are either zeros or ones. And it's also a particular kind of binary square matrix that has only 1 1 in every row and 1 1 in every column. So the usual use of a permutation matrix in general maths is to rearrange the order of elements in a particular matrix by multiplying by that P matrix. So if you see matrix X, there is a column matrix with 3 elements inside and the letters in the order T, A, R. If we pre-multiply that matrix X by matrix P, you'll hopefully see by what we know already from learning matrix multiplication how that permutation matrix manages to do that. So if you look at the first row of matrix P, 0, 0, 1, and we're looking at that column matrix TAR. So knowing what we know about running and diving in matrix multiplication, we can figure out what that first element should be in the answer matrix by saying 0 times T plus 0 times A plus 1 times R. So 0 times T and 0 times A and 1 times R. So if we work that out, 0 times T is 0, 0 times A is also 0, 1 times R is R. So our answer matrix, the first element will be R. If we're looking now in matrix P, look at the second row, 0, 1, 0. What that means is when I start multiplying for my second element in the answer matrix, 0 times T plus 1 times A plus 0 times R. 0 plus A plus 0 basically is A. And in the third row, 1, 0, 0, if I'm doing the matrix multiplication for the third row, 1 times T plus 0 times A plus 0 times R. 1 times T plus 0 times A plus 0 times R. So 1 times T is T plus 0 plus 0. So you can see there how just doing that by hand shows you how you manage to rearrange the letters TAR into the letters RAT. So it's sort of as simple as that. We can ask the same kind of question in a few different ways. The second example in your booklet asks us to find the P matrix or the permutation matrix. So it doesn't give us the starting point, it gives us the original matrix and the answer, and then tells us to try and figure out backwards what would P have to be to make that happen. So if we have a think about running and diving, for example, the first row has to be zeros and 1, 1. Okay, so I know there's only 1, 1 in the first row of this matrix across here. And I've got to figure out where that 1 has to go in order to pick up the D from here and put it into the answer matrix. So I've got to be thinking to myself, how am I going to pick up that D? So I'm sort of doing 0 times A plus 0 times B plus 0 times C plus 1 times D. So I need the 1 in this position so that that would run and dive, if you can imagine that the 1 is picking up the D as the fourth position to put in that first row in the answer. If I'm looking at the second answer, is a C, I've got to figure out in that second row to end up with the answer C, where do I need to put the 1 in order to pick up the C, basically. So again, I'm going to have 3 zeros in there somewhere and a 1 in the position that will pick up the C. So it's 1 times C equals C. So if you can imagine that the C is in the third position, third row in the original matrix there, and I want it to end up in the second row. So in my second row, I've got to put a 1 in the third spot, if that makes sense. In the third row of our matrix, the answer, oh, it should be B actually, I've got those written around the wrong way. So I should try to pick up the B in the third row of my permutation matrix. So we know that in our original matrix ABCD, B is in the second position. So I need to have a 1 in that second position there in order to pick up the B as I'm multiplying. So if you can imagine, it'll be like 0 times A plus 1 times B plus 0 times C plus 0 times D will give me the answer B that I need here. So the only one that's left, the final answer, I've got to end up with an A as my answer. And the only way I can do that is if I have a 1 in the first position. So it's 1 times A, 0 times B, 0 times C, 0 times D. So once I've figured out where the 1s go, that's the tricky part. The rest are all zeros. So as I know with a permutation matrix, I just do a quick scan. I should have in each row, I should have just 1, 1. In each column, I should have just 1, 1. And if you think you've gotten to the answer and then you say, okay, I've got to now figure out, is that correct? You can always put that straight into your calculator, do a quick ABCD and pre-multiply it by the permutation matrix that you think is the right answer. And if it does rearrange to DCBA, we know we're correct. So you've got to try and do these as quickly as possible in an accurate manner. So that's a second type of equation. The third type of example here is given, they give you the P matrix and they give you the answer matrix, but they want you then to calculate the original matrix. So again, we're sort of looking at this unknown matrix here, matrix A, and what I've got to put in to matrix A, I've got to have an X, a Y, a Z and a W somewhere in there. And knowing how multiplication works will assist me to figure out which letter to put in which position. So again, if you're imagining running across the first row of the permutation matrix, 0 times something plus 0 times something plus 1 times something plus 0 times something has to be X. So the only way I can get the answer of X is if the 1 matches up with the X, and I get 1 times X equals X and 0 for everything else. So the only way I can really do that is if my original matrix that I'm multiplying by the P matrix is if the 1 is in the position that matches up to pick up that 1 to give me the X in my answer. So 0 times something plus 0 times something plus 1 times X plus 0 times something else is going to give me the answer of X in the right position in that first row of the answer matrix. If you now think about the second row of the permutation matrix, what that will be saying is 0 times the first letter plus 0 times the second letter plus 0 times the third letter plus 1 times whatever is in this position here should be the answer Y. So the only way I can get Y in my correct position over there is if I've got Y in the fourth position in the A matrix. So 0 times something, 0 times something, 0 times something, 1 times Y. For the third row, 0 times something plus 1 times something. So this is picking up this position here in my original matrix, and I know the answer to that has to be Z, so my Z needs to go in here. And if you kind of think through the multiplication there, 0 times whatever's in this first position plus 1 times Z plus 0 times X plus 0 times Y gives me the answer of Z. And then in the final row, obviously I've got to pick up a W into the first position. That's the only one that's left. It has to be W. And if you imagine there that the matrix multiplication, 1 times W plus 0 times Z plus 0 times X plus 0 times Y equals W, which gives me the answer matrix in the right order. So again, once you think you've got the answer, you should then put it into the calculator if you think you need to. Do a double check.